notation. For scientific notation, we shall learn about large numbers, but there are enough videos out there, so I won't tell about the large numbers. So, scientific notation explains how we can represent very big numbers in a simpler form because, we can keep on writing digits and digits for an hour, so that will be boring. So, to do that, to do scientific notation, we just need to, now there are a few steps to turn a number into its scientific form. So, here is the simplest way. First, take your number and divide it by 10 continuously. And here you're going to do two things. If the number is bigger than 10, bigger than 0, that is, the number is bigger than 1, meaning it's not decimal, that is bigger than 10, something like that, then what you will do is divide by 10, but if it's smaller than 1, meaning it's decimal, then you will multiply by 10. So you keep on dividing until you get only one digit, and that is after the decimal point, and that's the unit place. And you should know dividing by 10. And we should use exponents to divide because it will make our writing, because that means that we'll have to write much less numbers. So after all this, the next step is to multiply or divide it. So, in case you are multiplying the number, then the exponent should be positive, and if you're dividing, then if you're multiplying, then the exponent should be negative to make the value the same. But if the number is bigger than 10, then you will have to basically increase. You will have to put a positive sign at the exponent. So after that, you put a time symbol. Let me give an example. Suppose we are converting 900 million into its scientific formation. So we keep on dividing by 10 until it reaches its minimum. Until it reaches the point where when we divide it more by 10 another time, it will become smaller than 1. So when we first divide it, we get 90 million, then 9 million, then 900,000, then 90,000, then 9,000, then 900, then 90, and then 9. Then you multiply, then that was dividing by 8, so the scientific notation is 9 times 10 to the power of 8. Let us try another example. This time we're going to choose 0.00004. It is not as small, but you can try it. Anyways, you might want to pause it at this and try this one on your own. However, in case you can't, I'm going to do it for you. So, for this, there are 4 zeros between the 0 and 4. So, we are going to multiply until it is at the point where it will be bigger than 1 if you multiply anymore. So, we have 4 zeros, divided by 10 we get 3, then 2, then 1 0, 0 zeros. Let us do that again, and it looks like that 10 to the power of negative 4. So, yeah. So, next step is to see what number is left, and we should get a 4. Then, the scientific notation is 4 times 10 to the power of negative 4. The reason why I chose this one easier than the smaller numbers when it comes to scientific notation. For really, really small numbers, it has so many zeros that I will have to say, I'd have to do it on a paper, but large numbers, most of them, not most of them, but some of them I could do pretty easily. In fact, this is a really good way to write really large numbers. For example, to write 9 million, instead of writing 9 followed by 3,003 zeros, which would be taking forever, the best way is to do the scientific notation, which is simple. It's just 9 times 10 to the power of 3003, which is a big number. However, sometimes the number, you don't need to use the scientific notation, and that is for numbers that aren't that are small, that aren't that small, that big, or aren't that big, that small. Like say 0.1 or 17, numbers like that, you don't need scientific notation. They are basically easy to write down quick. The scientific notation is just used when we're dealing with really big numbers or really small numbers. For example, the coldest temperature, the difference between the coldest temperature ever made on Earth and the absolute zero, or the hottest temperature in the universe, which was the Planck temperature, which happened 1 Planck second after the Big Bang. For those type of numbers, we need to use the scientific notation. And sometimes you will have to slow it down. For example, the weight of Earth is so much that I might not be able to say it, but I can say its scientific notation, which simplifies to be about 5.29 times 10 to the power of 23. Yeah, kilograms, which makes the Earth really, really heavy. But we are not talking about planets. But basically, scientific notation is for really, really big numbers or really, really small numbers, but not for moderate, medium-sized numbers, which are easy to write with very few digits, like 3 or 4 digits. That's easy to write down. Usually, I write 4 digits in my class. Anyways, that's